Welcome to the fourth module of the RiverTools Maintenance Training Kit. This module is preceded by a background lesson on the science of stormwater and 2 modules on green schoolyard vegetated practices, conservation landscaping, and rain gardens. Here, we explore a paving option. When you are walking, bicycling, or driving, do you notice the surfaces you are traveling over? Hard materials like concrete, asphalt, or bricks are common. These are chosen for their strength and durability. But watch them in the rain. Water will puddle and pond because it cannot pass through and does not soak into the soil below. Permeable pavements, however, are different. These surfaces are engineered to let the water in. Rainwater that puddles and ponds on our playgrounds, sidewalks, and roadways becomes stormwater, carrying dirt, oils, and all manner of pollution to the nearest water body through storm drains. If you are in the District of Columbia, the rain falling around you is headed to Rock Creek or the Anacostia or Potomac rivers. During heavy rainfall, streets may flood temporarily, but even those waters will eventually end up in the Chesapeake Bay. Permeable pavement can help protect the quality of our rivers and the bay. By allowing large amounts of rainwater through paved surfaces, we help restore the natural water cycle and minimize the polluting effects of our city. Permeable pavement materials have unique and interesting properties, but their ability to absorb rain and remain strong relies on strategic layers of specially selected rocks or aggregates. These rock layers may be a few inches or several feet deep, and this depth will be decided based on an array of factors, from the amount of area draining to the pavement, the contour of land, and the type of allowable traffic. Permeable pavement are systems with 3 main components: the surface to let the water through, the rock reservoir to store it, and a combination of underdrains and underlying soils to give the stored rainwater somewhere to go. In some parts of D.C., the soils below existing sidewalks and roads have the capacity to absorb rainwater. But in some parts of the city, the soils do not. If you are in an area of the city with clay soils, a permeable pavement system is certain to have an underdrain to slowly release the stored rainwater back to the storm drains long after the storm is over. Knowing the parts of a permeable pavement system and how they work will help you spot the maintenance challenges and remember the do's and don'ts when you are gardening nearby. There is an ever-growing market of innovative surface materials used for permeable pavement systems. The 3 most frequently used in green schoolyards are porous asphalt, pervious concrete, and a range of permeable pavers that can be pervious themselves or rely on the aggregate-filled joints between the pavers to create permeability. Pervious concrete is made of the same ingredients found in conventional concrete. The difference is in the amount of the fine-grated sand left out, creating a popcorn-like matrix with space for the water. Similarly, porous asphalt is made of the same ingredients found in conventional asphalt. The difference is found in the type of binder used, also creating the popcorn matrix with void space for water. With interlocking concrete pavers, the paver itself is a traditional concrete and impervious. The system's permeability comes from the aggregate in the joints between the pavers. Permeable pavements installed at RiverSmart schools may be more challenging to identify than the conservation landscapes or rain gardens, but they are an important part of the schoolyard greening effort. If your team is committed to RiverSmart's success, you will want to be able to recognize permeable pavements, troubleshoot their challenges, and know the do's and don'ts for working around them. Some permeable pavements are easily identified by their distinct patterns and the aggregate that fills the space between the blocks. However, many permeable pavements are challenging to distinguish from their conventional counterparts unless you can observe them during the rain. If you are maintaining a landscaped area on school grounds during a dry period, it is a good idea to consult the school facility manager to have all permeable pavements on site located. When you know where they are, you can take precautions to protect them. Once located, how can you tell if these permeable pavements are working properly? If you are not a professional contractor in the maintenance industry, you will be limited by your tools, but there are important actions you can take. Visual inspections are the key. Throughout the pavement's first 6 months, the rock reservoir storing rainwater below the surface may compact. This settling can cause surface cracks or dislodge pavers. If you are watching and see settling, say something. An installation is typically under warranty for the first year, and this can be repaired. Over the life of a permeable pavement system, observations after large rains are essential to spotting problems. Throughout the growing season, when mulching and mowing are common, rain can move these materials onto the pavement. If these are not regularly swept, they will clog the pavement pores, providing spots for weeds. If the growth exceeds what minor hand weeding can manage, action with a weed burner may be required. Often, untreated, the buildup of sediments and weeds will lead to extensive clogging, and ponded water will become apparent after big rains. Alert the appropriate manager to ensure this maintenance is performed. Vacuuming, low-pressure washing, or regenerative sweepers can be used to restore the permeability of these pavements. Permeable pavements maintained with sweeping machines on an annual or semi-annual basis rarely clog. If pavement is installed in a high leaf litter area, monthly or even weekly machine sweeping could be required. You will need to watch periodically during the winter when de-icing and plowing are in use on pavements. Spreading grit or sand to create grip will clog these pavements. If you see sanding, say something to the school facility manager. Salting has a negative effect on water quality and is a significant problem for pervious concrete. Salts can cause the concrete surface to unravel. Avoid sands and salts around permeable pavements. Use environmentally safe de-icers. Remember, identify if your RiverSmart school site has permeable pavement. Have a wet weather inspection plan. Sweep surfaces and weed weekly, or as needed. Alert managers if you observe surface cracks or dislodged bricks. What you don't do is as important as what you do. Avoid actions that can contribute sediments, discourage weeds, because sediments and weeds are the main causes for clogging. Avoid actions that might introduce chemicals. This adds pollution to the rock reservoir below. With minimal attention, following these simple precautions, the permeable pavement should provide years of stormwater service, protecting our streams and rivers.